We can see another example here. So below here is the controller output and error is the above here. So we are going to start the analysis of the PD controller. So if we look at the first part of the error here is 0. So the 0 error here meaning that we have no slope, or we can say the error slope is 0. So therefore we have the controller output to be 0, the PD output to be 0, and plus on top of that is the P bar, which is the nominal value without error. So it shows in this case the P bar is 50%. Next, the error occurs here, the first slope and the second slope. So we can see that the first slope is steeper than the second slope. So but both slope shows the positive value of slope, which means that if we take derivative function of these two slopes, we should have positive value similar like this. So we have 50% here, and we have plus some derivative value. So the first slope shows higher value of derivative as compared to the second one. This can be seen clearly from the slope value. So the first slope is higher, steeper than the second slope. So we have the first derivative value higher than the second value. Third, we have a flat constant value of error, which means if we take derivative function of this line, we don't have any slope. Therefore, the derivative value of this line will be 0. So 0 means we are going back to the 50%. Later, the error reduces and we have reduction over here, which means that the slope is negative. So we have during this period of time, the controller output will be 50% and minus some value. So it will be dropped below 50% to represent the negative slope. So that is the total response of the controller output if we analyze the derivative control output.